Hey, fellow problem solvers, Colfax Math here. IB Calculus, IB Math, SL, Analysis and Approaches, Topic 5 Calculus. So today we're going to go over kinematics. Not really for a physics class, it's all really the same, but we are looking at kinematics from a calculus point of view. First thing we have is displacement, and that is represented with ST. Displacement and distance are two very different things. Let's say I had a point right here and another point right here, 50 meters away. The distance from here to here and then back again would be 100 meters. The distance is the total distance traveled from here to here. The displacement is how far am I from home. Well, the displacement after this, after I go there and back, is going to be 0. The displacement here would be 50, but after I come back, the displacement is 0. So that's one of the most important things to note with displacement. You know, if I have a point from here to here and I travel all of this distance to there, the distance is the length of that long line pulled out straight. The displacement is a distance from here to here in a straight line. So first we have displacement, that is S of t. Then after that, if we take the derivative of S of t, that gives us v of t, which is velocity. Velocity is the first derivative of S of t. So velocity is equal to the derivative of displacement. And then after displacement, velocity, acceleration. And acceleration is going to be the derivative of velocity. So we could take the derivative of velocity to get acceleration, or we could take the second derivative of displacement. So to go from here to here, we take the derivative. To go from here to here, we take the derivative. We derive velocity from displacement. However, going backwards is going to be the integral or the antiderivative. So if you are given acceleration and you want to go to velocity, then you would integrate. So you'd have to take the integral and go backwards here, and then take the integral and go backwards here. We're not going to do that just yet, but it is important to note that going this direction from displacement to velocity to acceleration is a derivative, and then going back this direction is an integral. Okay, let's say we are given a particle moving in a straight line and its position is S of t is equal to t cubed minus 3t plus 1. That is its displacement. And then if we were asked to find its velocity and its acceleration at time t, the velocity v of t would be equal to the derivative of this. I'm going to use my rules of derivatives. That 3 comes down in front, subtract 1 to get 3t squared minus 3. And then from there, if I were asked to find the acceleration of my displacement, I could take the second derivative of that, or I could just see that the acceleration is the first derivative of the velocity. Use my rules of derivatives. Power rule, 6 comes down in front, and I get 6t. So now I have my displacement function, my velocity function, and my acceleration function, all from taking the derivative. Now if the problem says find the initial position, velocity, and acceleration, the initial is at t0, so I'm going to set 0 in. So S of 0 is going to be equal to my position at t equals 0. 0 cubed, 0 minus 0 is equal to 1. What is its velocity at 0? The velocity at 0 is 0 squared times 3, 0, minus 3. What is the acceleration at the initial position, or the acceleration at t equals 0? 6 times 0 is equal to 0. Now let's say the problem says describe the motion of the particle at t is equal to 2. The motion of it is going to be its velocity. So the velocity at 2 is going to be equal to 2 squared 4 times 3, 12, minus 3, 9. So at t equals 2, the velocity is 9 meters per second going away from me. And then the acceleration at t is equal to 2 is going to be equal to 12 meters per second squared. It is accelerating away at 12 meters per second squared. And the velocity at t is equal to 2 is 9 meters per second. Okay, now let's look at another problem. Let's say, at what time does the particle reverse direction? So at what time does the particle reverse direction? So what we're saying there is that velocity is equal to 0. So at what time, what is the value of t when velocity is equal to 0? I'm going to take my velocity right there, 3t squared minus 3, set it equal to 0, and solve for t. So let me just read that wording again. At what time does the particle reverse direction? So it's going to move, come to a 0, via t will be 0, and then go the other way. So I'm going to solve for t here. Add 3 to both sides, 3t squared equals 3. Divide both sides by 3, and t would be equal to 1 when that particle reverses direction. If the problem said, at what time does a particle start to speed up, it's going to be t is greater than 1, because that time is the flat spot on the graph. And we'll take a look at that graph. Actually, let me click over here to Desmos. So in Desmos, in red right here, we have the movement of the particle, t cubed minus 3t plus 1. And then in purple here, we have its derivative. So red is displacement. Purple is the first derivative of red, meaning the velocity. So what I'm saying here is anything below here, it is negative displacement, positive displacement, negative displacement, positive displacement. And we could see here that this is 5 units. So at 1, it changes from negative to positive. So as we're looking at the position vector, anytime it's down here, it is going to be negative, positive, negative, positive. And then as we take the derivative of that, which is going to be the slope, right? As I look up here, as my slope is positive, 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 stops at 0, right? So now the derivative equal to 0, and that's why velocity crosses at 0. Negative slope to here, and then all of a sudden again the slope is 0, and that's why my velocity is 0 right there, and then back to positive slope. So if the problem says, what is the total distance traveled by the particle between t equals 0 and t equals 3? So between 0 and 3, what is the total distance traveled? So this is what we're talking about right here. So what is the total distance traveled? So we have to take absolute values for distance because we don't care if it's positive or negative. So I'm going to take these values, and I can see that 1 is going to be my critical value right here graphically. So let's go back to our paper here. And I know that t is equal to 1. I am asking distance traveled, so that's going to be s of t. So I'm going to figure out s of 1. I'm going to take that 1 and plug it in here. S of 1 is 1 cubed 1 minus 3, negative 2, plus 1, negative 1. And we're looking at the parameters between 0 and 3. So what happens between s of 0 and s of negative 1? What's the distance traveled? S is 0, 0, minus 0 plus 1. So the distance traveled between 0 and 1 is going to be 2. And then the other side of what I'm looking for, distance traveled between 0 and 3, I'm going to find s of 3. What is that distance traveled? So s of 3, I plug it in here to get 27, minus 9, 18, plus 1, 19. So what is the distance traveled between negative 1 and 19? It is a total distance of 20. So what is the total distance traveled between 0 and 3? It is going to be the 2 meters plus the 20 meters, or 22 meters. Quick overview of kinematics. Big takeaways is that this is displacement, not distance. Velocity is the first derivative of displacement. Acceleration, the first derivative of velocity. So going this way, you take the derivative. Going back up, you're going to take the integral, the area under the graph. Thank you for watching.